In today's video, I want to take a look at the syntax that it took to declare classes in like before ES 2015. So it ES5, ES3, and so on. Well, suppose first we want to declare a shape class. All right, I want a shape class, and I want that shape to have a position, so an X and an Y. That's all I want. How would I go about that in ES5? Right, so we don't have the class keyword at all. What we have to do is first define sort of the constructor function. So what's that? Well, that's basically just declaring a function with the name of the class. And that is, let's say, shape here. Right, and this guy will take in the parameters that a usual constructor would take. So I want just X and Y. That's fair enough. A bit strange that you have to declare a function for a class, but we'll get there. Next, well, you can use the same code as in any other object-oriented language here. So you can use the this.x equals x. So we would assign the x parameter that was passed to the constructor to our instance of that class, right? And then the same thing with y. So that's fairly straightforward, right? If you've seen classes, that's still kind of familiar, except for that function keyword, but we'll get there. Next up is, well, how do you define functions inside this shape class? Well, the first way to do so is by just kind of plopping them inside the constructor. Right, so you would go about and start setting it here, say this dot, let's say move equals a function that takes in, let's say, the offset on X and the offset on Y, right? I'm gonna shorten the names of every variable here just because we don't want to write too much. And what we want here is to just add these values to our X and Y value. That's all this function is going to do. So I'm going to say this.x plus equal the offset of X, and this.y plus equal the offset of Y. Offset of Y, come on. Like that. So what we have here is kind of a class, really a function that holds all the properties and all the methods as well. So if you want to use this, well, that's very straightforward. We just say, let's say let's call it sh equals new shape, right? So new shape, and then we pass in the constructor parameters like in any other language. Let's say I want this to be at 0, 0. Simple enough. And then suppose I want to also move it. So I'm going to say sh.move, and I'm going to offset it by 5 on the x-axis and then by 10 on the y-axis, for example. And if I add a breakpoint here and run this whole thing, right, and go to the debugger here, and let's add our variable here. So I'm going to say sh, and while it's undefined so far, if we step over the declaration here, you'll notice I'll get a new shape, and that shape has three things: has a move function, has an X and a Y. That's straightforward. And then if I execute this as well, you'll notice the X and Y values change because our this was the shape itself. Okay, so that's, so far I think it's straightforward. We still are using the new keyword. We just need to have function instead of class, and that's all there's different between that and ES6. One interesting thing to note is that we're using the new operator on a function, not really on a class. So how does that work? Well, basically, when using the new operator, what it does is first create an empty object, and then it takes in that function, right, that shape, and it calls it, actually calls the call function with that new object that has been created. And then of course adding all the other arguments. So our 0 and 0 here would go. Okay, so this is what it would do, and at the end of this whole thing actually return our object that has been created from this function. Right, so if we were to just call this, we wouldn't get anything as a result, but because of the new operator, we would in fact technically return this at the end of the function. So I hope this sort of makes sense. This is how the new operator works on JavaScript functions. Now this method gets much more complicated once we add inheritance into the mix. So if I want to, for example, create another class called, let's say, square, so it's going to say here function square, and this square is going to still take in our x and y, but it's also going to have a size. So let's say here size. Okay, and well, what do we do here? Because we need to call the constructor. If we want this guy to actually inherit from the shape, we want to call the constructor of the shape. Well, we can do that. It's just in a very strange manner. Right? You cannot just call shape with x and y due to the fact that the way that this keyword works. So I made a video previously about the this keyword, and here is the situation where you're calling a function without any calling context. And because of that, what you're gonna get is the global context being passed along, right? And because of that, we don't want our this to be the calling context. So to do that, to fix all that, we have to actually use a different function to call this shape function, and that is shape.call. And this guy is sort of an intermediary, but instead of only just passing in the parameters, we can actually pass in, if we take a look at the documentation, we can actually pass in the this argument. So now what we can do is pass the this from inside our square function. So then this guy actually corresponds with this, so when we call it, it's going to add the x and y fields to our object. Okay, this is how you would call basically the super class inside inside the old ways to actually instantiate JavaScript classes. And then of course let's also add the size. So this dot size equals size. Now, if we, for example, change this to a square, so if I go here and change this to a square and say I want a square at position 0, 0 with the size 10, okay? And I also want to move it later on. So if I run this now, you'll notice that if I step over the declaration here, we get a square here with the move function from our shape with the size, that's 10, with the x, which is 0, and the y, which is also 0. So this is very nice. Okay, so we have both the size from the square constructor and x, y, and the move. I wonder what happens if we call the move function on this. So if I try to run this, you'll notice I'm also going to get the positions changed. Now there's one big issue with the way we're doing things so far, and that is with the move function itself. While sure, we get the move function inside the square here, every time we actually create a new square or a new shape really, we're actually creating a new move function, right? So if we have here, let's call this SQ from square, actually let's do SQ1, and suppose we have SQ2 as well. And we do new square of, I don't know, let's say 1, 5, and this guy is a bit bigger. Why not? And the sq1.move function will actually be different than the sq2.move function. There will be completely separate functions created for every single instance of that, well, of that class. So we have to somehow prevent that, and to do so we're going to have to change the prototype of this function to actually create a single function that just kind of changes its this parameter every single time. To do so, what we have to do is just say shape.prototype and then dot whatever function we want to create here. So let's say dot move equals our function here. And then I can remove this, and then I can actually add a semicolon here, and now everything almost works. If I try to run it now, so now we're only going to get one single instance of this function because, well, this code is only going to be executed once. The only issue is that if I try to step over all this, sq1, let me actually change this to sq1. There we go. It has x and y 0, size 10, but doesn't have the move function anywhere, as you might notice. And if I go to the prototype, no move function anywhere. So if I step over this, well, I'm gonna get an error. Okay, so that's an issue. Now we no longer have the move function, even though we added to the prototype. Now this issue is with the square. If we, for example, instantiate another just shape here, not a square, and if we, let's say 0, 1, and then we try to move that shape, let's say by 10 and 40, why not? And if I breakpoint here, well, if I go over it, you'll notice that our shape, right, our shape instance, not our square instance, has the x equal to 0 and the y equal to 1. And if I go to the prototype, it has that move function. So that means that if I run this code, our x and y values changed properly, because that move function is on the shape class, but it's not on its child classes. So basically, since square extends the shape class, it's not actually there, because we have added it to the prototype. Now we have to sort of get the prototype of that shape and add it to the square as well. How do you do that? Well, there's a snippet of code that you have to add here after you actually define the function class, or however you want to call it, and say square.prototype. So the prototype itself equals, well, you might be inclined to just say shape.prototype, but that's not correct, because then you're going to have the same prototype on both of them, right? And what we want to do is just create a new object that has all the properties of that prototype. So I'm going to say object.create of shape.prototypes. So now what's this going to do? Well, it's going to take all the properties and values of this prototype object, create a new object that has those, that's completely different than this guy, and assign it to our square.prototype. Right, so now both square and shape would actually share this move function, and it will only be just one instance of that function. Okay, so now if I try to run this, you'll note that, well, if I go over the shape part, that still works, that's very nice. But if I go over the sq1 part, right, I have here the square, size 10, x and y 0, that's correct. And if I go over this guy, of course it also works, because now the square actually has the function move inside its prototype. So finally, we have created a, well, two-class system, one inheriting from the other, in which we have a function that is shared between those two. So it's just one instance of that function, no problem, because in some situations you might want to actually change that function at runtime. And if we were to change this function, then it would change it for all the instances of those classes, right? Either shape or square. Now, if you're using Visual Studio Code, you could actually transform this whole code into ES 2015 classes, and those are usually supported by any modern browsers. So if we navigate to the shapes constructor function and hit Ctrl dot here on Visual Studio Code, you'll notice it brings up a suggestion saying that it can automatically convert the function to an ES 2015 class. So if I hit this, you'll notice I get a normal class, a constructor, and a move function. So it automatically does it for us. So you'll notice the difference, that it's pretty big and it's not that straightforward. We can do the same for the square class here. So if I do this, you'll notice it almost changed everything properly except this part. So we're going to have to actually, instead of saying shape.call, we're going to have to say supper x and y. Okay, and we're going to have to say here extends shape. Right. And of course, we don't need this anymore. So now, if we try to run this code with the shape class being properly made with, well, newer syntax, and the square one extending that shape class, well, you'll notice that our shape has the 0 and 1, x and y here, and it can also move, and our square also has 0, 0, and 10 for the size, and then it can also move as well. Okay, so everything now works properly. Do keep in mind that the newer syntax you saw there, it's behind the scenes, it's actually doing something like this code. So you still have the same functionality, just it's much easier to use. Okay, it's much less prone to errors. One more detail that I omitted is if you wanted to add a function to the square class, you have to make sure that you add it like after this sentence. Because, for example, if I were to copy this and suppose I want it to the square, I want to move 2, for example, this is fine because it's adding to the prototype of the square, right? But if I were to move this up here, you'll notice that, okay, we're adding the move 2 function to our prototype, but then we're overriding the whole prototype, right? So this won't work. So there are many things that you should be careful with using the old way of defining classes, right, in ES5. Now, there are a few reasons I actually made this video. One is so that you actually become familiar with this old way of doing the ES5 classes, but not for naught, because this way is much more compatible to more browsers than the ES 2015 way. So what you're gonna see is a lot of code that breaks down to this format once it enters production. And the second reason is that there are some old libraries that still use this manner of creating classes, and you shouldn't really be scared of them. They are just a different way to create classes, and if you understand these basic concepts, you're gonna actually figure them out and it's gonna be fine. So I hope you learned something from this. If you do have any questions, please do leave them down in the comments below or on our Discord server. Thank you so much for watching. Take care. Bye.